Good evening, girls. So now we are going to discuss a new topic called thread priority. So with this class, we will be completing the total of multi-threading concept. So we have seen what a thread is and how the threads are created concurrently and the life cycle of a thread. And next we will see how the threads are given priority. Okay, so each thread is assigned a priority which affects the order in which it is scheduled for running. So when there are a number of threads which are waiting for the processor time or allocation of the processor, automatically they should be assigned some priority if they need to be uh, executed a little bit earlier compared to other threads. So this is what we call priority. So generally in general sense also we give priority to some important works, and we give more priority to some important works, and we give less priority to the works which can be done later. So that same thing applies here also. So a thread is given priority which will affect the order in which the processor time is allotted to it. Next, the threads of the same priority are given equal treatment by the Java scheduler, and therefore they share the processor on first come first serve basis. If all the threads in the queue which are waiting for the processor which will be in the runnable state are of same priority, then the Java scheduler will give them the equal treatment, like the no partiality or no priority is given. Okay, so they will be executed in the order which they are coming, first come and first serve. So whoever comes first, he will be allotted the time, the thread with that thread will be allotted the time, and after that the next and the next. If you want to change the priorities of the thread depending on the type of work that thread does, so you have to use this set priority method. So the Java gives us the option to set a priority for any thread by using this set priority method. So this is the syntax of this method: thread name dot set priority in bracket int number. So int number is nothing but an integer value to which the thread's priority is set. So actually some values are predefined values are set to which these threads are given, assign these values. Depending on the value, you can decide what kind of priority is given to that thread. So generally there are three primary constants. The thread class defines three priority constants. So first one is minimum priority, which is nothing but 1, and normal priority, which is 5, and maximum priority is 10. So the priority ranges from 1 to 10. So the minimum is 1 and the maximum is 10, and you can give any value in between, right? So normally, generally, every thread by default will have a priority of 5, which is called normal priority. So that is allotted, that is given, assigned to any user level process. Okay, so and the default setting is normal priority. So by default, when the thread is created, the priority to which it is set is 5. Okay, so most user level processes should use norm priority plus or minus 1. So the user level process, the works which the user does, are given normal priority plus 1 or minus 1. Background tasks such as network input output, connecting to the internet, uploading or downloading, and screen repainting, they are given the lowest limit, like near to 1, because this those works are background tasks. They should not be given such importance, more importance when compared to the user level tasks. Next, we should be very cautious for using this higher priority values, because if you go on changing the priorities which are the, or you override the priorities which are set by the scheduler, that will cause a lot of what you say lag between the threads, which will defeat the whole purpose of using the threads. Next, by assigning priorities to threads, one can ensure that they are given attention or lack they deserve. So when you have a very most important work which has to be done by a particular thread, then only you try to interfere with the priorities of the thread. Otherwise, all the threads which are created are by default given by normal priority. So that is well and well and good for a thread to get executed. So whenever multiple threads are ready for execution, the Java system chooses the highest priority thread and executes. So when there are n number of threads in the queue, in the runnable state, so the thread with the highest priority will be chosen to execute first. Okay, so for a thread to gain control, okay, for a thread of lower priority to gain control, if already the processor is executing the thread with higher priority. Now the thread wants to, a thread with lower priority wants to gain the processor time. Then what should happen? Because higher priority threads will always be executed by the processor, or equal priority, when there are equal priority threads, they will be executed in the first come first serve basis, right? So three things should happen. Any one of these things happen, then the lower priority thread will gain the processor time. So the first one is it stops running at the end of run. So the thread has finished execution. It has completed its run method, the statements which are written in the run method. In such a case, the lowest priority thread will gain control. Next, it is made to sleep using sleep. Okay, if the thread is put to sleep by using the sleep method, it is told to wait using wait method. So it is asked to wait for some time, for a fixed amount of time by using wait method. So any of these three things happen, then automatically the thread which is having lower priority will gain the control. When the thread which is getting executed by the processor is put into any of these three conditions, either it should go to sleep, it should wait, or it has completed the execution, and that is, it has come to the end of the run method. Okay, next, if another method of a higher priority comes along, the currently running thread will be preempted by the incoming thread, thus forcing the current thread to move to the runnable state. So, see, a lower priority thread will gain the control when any of these three things happen. That is, it finishes the execution, or it goes to sleep, or it is waiting for a specific amount of time. But okay, now the lower priority thread has gained control. Fine. Now in the queue, a new thread has come with a higher priority than the thread which is currently getting executed by the processor. Then what happens? Then this thread which is having the lower priority will be preempted. 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 That means it will be set aside. It will be kept aside. It will force it to move to the runnable state. It will be stopped. It's stopped in the sense it goes to dead state. It will be asked to move from the processor and go back to the runnable state, so that the higher priority thread which has come from the queue will be allocated by the which will be executed by the processor. So for the most important thing that you have to remember is the highest priority thread always preempts any lower priority threads. So if some threads are getting executed by the processor and there comes a highest priority thread in the queue, so this lower priority thread which is getting executed by the processor has to leave the processor and go back to the runnable state and wait in the queue again, because this highest priority thread will preempt. Preempted means it will push us, it forces, it asks to abruptly end the leave the processor time and go to the runnable state. So this is about your threads, and we are seeing a program here. You are taking 3 threads, thread A, thread B, thread C, okay, and you are executing them, and you are also setting see priorities to those threads, maximum priority, minimum priority, okay, and you're trying to print them and see this is how they will get executed. So when B is given the maximum priority, yes, A is given the priority or B is given the priority, maximum priority to minimum priority, then they will be leaving and see here. Thread B, thread C, thread B, and finally thread A, because A is set to the minimum priority. See, set thread A dot set priority, thread minimum priority. Okay, so the maximum priority is given to thread C. So thread B and thread C get executed first. Okay, so see, it's starting thread A, thread B, thread C. Thread B started. So after 2 iterations of execution, thread C gets started, it gets completed, then control gets back to thread B, and finally it will come to thread A, because A has been set to the minimum priority and B has been set to the C has been set to the maximum priority. So it will take the lead from B and executes the whole, I mean, it completes its whole process, and then it hands over to the processor to be, I mean, the processor will take up the. This is about your thread priority. Next, thread synchronization. So, what is synchronization? See, synchronization is nothing but when two methods are trying to operate on the same set of data, and one method is trying to just read the data, but the other method is trying to modify the data, I mean insert or delete or change the values in that particular method, then there comes some problem. And also when methods complete for the same resources, like method A is also asking for a printer and method B is also asking for a printer, so there it will cause a lot of deadlock situations. When the computer enters into deadlock situation, it is very much difficult to solve the problem. See, when one thread is trying to write into a file and while the other read from a file, when the other is still writing I mean updating the file, so these kind of situations occur. So to avoid these kind of situations, Java has a concept called synchronization. So what is synchronization? Synchronization is nothing but these threads have to be noticed prior that they are using this particular resource for a particular period of time, and no one can use this method till this thread completes the execution. That is what is synchronization. So how you will define whether a method is synchronized or not? See, the first thing here is this method of update method is set as synchronized. So when we declare a method as synchronized, what happens is Java software creates a monitor and hands it over to the thread that calls the method first time. So when a thread which is trying to execute this particular method, when it is calling that particular method, Java creates a monitor and it gives it to thread. So as long as the thread holds the monitor, no thread can enter the synchronized section of code. So when a thread is using that particular method, and which is declared as synchronized. That means the thread is holding the control over that particular method, and no other thread can come and try to ask for that method. So that is what is the use of monitor. So this monitor is very much similar like a key, and the thread that holds the key can only open the lock. So a monitor is like a key. So whenever a thread tries to execute a code which is set as synchronized, automatically it will gain the control of the monitor, and only the thread which has this monitor can execute the thread, vice versa. So a monitor is like a key, and the thread that holds the key can only open the lock. So whenever this, you can consider monitor like a key and the thread like a lock. So the thread can open that lock only when it has the monitor with it, right? Next, this is how a synchronized code looks like. Next, whenever a thread has completed its work of using synchronized method or block of code, it will hand over the monitor to the next thread that is ready to use the same resource. So when the thread completes its work, then automatically it will it will leave the method. It will hand over the uh, execution, it will hand over the control to the next thread which is asking for this same resource. So if you don't do this kind of synchronization, what happens is two or more threads waiting to gain control of a resource. In such a situation, it will give rise to a situation called deadlock. So deadlock, and see, thread A will be asking for method 1. See, A is having access to method 2, B is having access to method 1. But if A has to gain the control access of method 2, it has to gain access of method 1, which is under the control of B. And if B has to release method 1, it has to gain control of method 2. So mutually both are waiting for each other to release the methods, which is causing a situation called deadlock. So when you use this synchronized keyword and put these two methods into a synchronized state, then automatically you can avoid these kind of situations. Next, implementing the runnable interface. So we have seen that threads can be created by using thread class and extending the thread class, and by implementing the runnable interface. When we will come to the runnable interface, create a thread using runnable interface, implementing runnable interface, when, because you have other class to extend, that class has to extend some other class other than the thread class, and we have a limitation that Java will support extension. It can extend only from one single class. It cannot extend from two or more classes. That is the reason we will be using this implementation of runnable interface. So when you are implementing runnable interface, so these are the steps that you will, we have to do. Again, this runnable interface has run method, okay, which is the main method for required for implementing the threads. First one is declare the class as implementing the runnable interface. See here, class X implements runnable. Runnable is nothing but the interface. That is the reason we are using the keyword implements. Next, implement the run method. So you are writing code for the run method. Create a thread by defining an object that is instantiated from this runnable class as the target of the thread. So you will be creating a thread. See here, thread X, okay, and it is instantiated by creating an object so that it will execute this method, run method, which is defined in the class X. So creating a thread by defining an object that is instantiated from this runnable class as the target thread. Next, call the thread's start method to run the thread. So always you have to make the method, execute the method or make the thread run by using the start method. So this is the program. So you see, you are creating a object X for this runnable. Okay, so runnable, you are creating a new object, and you are also creating a thread X. Okay, new thread. Okay, you are passing this object to this thread runnable, and by using this thread X, thread name dot start, you are starting the executing the method run of this class X. Okay, so this is how your thread gets executed by implementing a runnable run interface. Next, see, these are the methods of thread class. So just go through them, like see what is the priority of the particular thread. Okay, see, daemon thread. What is daemon thread? The threads which do background works are called daemon threads. Okay, so is it the thread interrupted or is it running? You can use these methods to check the condition of the thread, in which state it is, what value it returns. So you can write you can learn any of these, any 4 to 5 methods, and write them in the, include them in your answer, which will fetch you more marks. If you don't write also, it is not a big deal, but if you include them, then it will fetch you a little bit more marks. And see, this is the difference between the wait and sleep method. So it can be asked as a 4 marks question. So what is wait? What wait belongs to object class, and sleep method belongs to thread class. Okay, and where wait can be used, it can be used with synchronized method or statements. The methods which are declared as synchronized, only with those kind of methods you can use wait. It can be used outside synchronized, apart from synchronized methods and statements, it can be used anywhere. Sleep method. Wait state can be terminated by calling object.notify. So when a thread is in wait state, you can take the thread out of wait state by using this notify method. And if when it is in sleep, if you want to stop, get the thread out of the sleep state, then you can use this interrupt method. Okay, next, object.wait is used in concurrent thread access codes only. When the threads are executed concurrently, simultaneously, parallelly, then only you can use this wait method when you want to stop any one of those methods. Next is used whenever thread sleep method can be used whenever and wherever required. There is no conditions set, like it has to be used with concurrent threads only or like that. Next, it stops the thread execution and releases the lock of the object. So when you suppose a thread, when you ask a thread to move to the wait state, it will stop the thread execution and releases the lock, because it is working with synchronized method. So synchronized method is nothing but it will have a monitor, right? So that monitor has to be released, so that lock is released. Now other threads can use this released object. Next, when you use sleep method, the current thread is suspended for some amount of time. This is MS stands for milliseconds. This be within this amount of time, for such amount of milliseconds, other threads can use the resources which are used by this thread, which is sent into sleep mode. Okay, so this is about your multi-threading. If you have any doubts in this concept, let me know in the group, or else we will have a Google Meet class and clarify those doubts. So we will move on to the next topic. I will send you the notes. So once you finish this, you start updating the notes, and after that I will send you the videos. Take care. Bye.